0.1111. So if I do this forever, do you all agree that this would have turned out to be 0.111 forever, like that? That's what it would be. Do you all agree with that? Okay, now, believe it or not, that's the fraction 1 over 9. So if you get on your calculator, type in 1 divided by 9, you're going to get 0.111 forever. So what does that tell you? It's not going to fill it. It's only going to fill it, what? 1/9 of the way. So you're not even going to fill this up halfway if you do this. You're just going to get closer and closer to 1/9 of the cup. So it's going to start coming up, but it's going to never get to 1/9 unless you could do it forever. If you could do it forever, then you would reach 1/9. But how could you do it forever? This is weird, right? But this is, so the math is settling it for us. This cup will not overfill. All right? I'll try and throw maybe one of these little random things in every class just to kind of keep us thinking a little bit. All right? Back to the other stuff now. Unless y'all don't want me to, I don't have to do that stuff. Okay, adding and subtracting fractions. You ready for this part? So when it comes to adding and subtracting fractions, what's the most important thing? You have to have the same denominators. You have to have a common denominator. So because we have addition, we must have a denominator in both of these that are common. And what we mean by that is that we have to have a number down here that is a multiple of both of those. So if we list the multiples of 8, that's 8 times 1, that's 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6. Those are all the multiples of 8. And then we can look at all the multiples of 5. And what we're looking for is, we're trying to find the smallest one that's in both lists. So 40 is our, what we call our least common denominator. So I'm not going to do this every time, but this is what we're doing kind of mentally. We're thinking about all the multiples of 8 and all the multiples of 5, and we're trying to figure out what they have in common. We're trying to look for the smallest one, which is 40. So what that means, I need to turn this 8 into a 40, and I need to turn that 5 into a 40. And the way we do that is we multiply each fraction by the number 1. And the reason we multiply by 1 is because if I multiply anything by 1, it doesn't change, right? What's 10 times 1, right? 10. What's a chair times 1? It's still a chair, right? 1 doesn't change anything when we multiply. But the way we write this one, we get very clever with it. To turn the 8 into a 40, we have to multiply it by 5, right? So I'm going to rewrite the 1 as 5 over 5, right? I'm going to multiply that times the 1 over 8. And then plus, over here I have the 2 over 5. I'm going to multiply that one by what? 8 over 8. Does everyone see that all I'm doing is I'm just being clever? And it's not me. I mean, this is what we as human beings have done. We said this we need to add. We need the same denominator. If I change this one, multiply by 1, which will be a 5 over 5, that's 1. Then this will now have a 40 on the bottom. And if I do 8 over 8 here, this one will have a 40 on the bottom. And then I can add them together. So now my next line reads these two multiplied. So there, just go straight across, which would be? What's that? 5 over 40. Okay, and then plus, then you do these two. 16 over 40. And now that we have the same denominator, we can add. And how do we add fractions when they have the same denominators? How do we add them? What's the bottom? 40. So you don't touch the bottom. You leave the 40 the way it is. And what do you do to get the numerator, the top? You just add these up across. So 5 plus 16 is 21. 21 over 40. There we go. So that's the way we add fractions. We get a common denominator, and then once we have a common denominator, we put them together, right? And then we just keep the denominator and add straight across. What if this was a subtraction? What if that was minus? That would be minus. That would be minus. And then what would 5 minus 16 be? Uh-oh. Negative 11. 5 take away 16 would be negative 11. So if I change that to minus, 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 then 5 take away 16 would give me negative 11 over 40. All right, is there another way to add fractions? Has anyone ever learned a different way than what I just did? There's a shortcut. Would y'all like to see a shortcut method? Now, there's pros and cons to the shortcut method, but it works really good here. Let's go back to the original problem right there. Now, if you're okay with what we just did, we don't need to worry about it. We can just stick with what we just did. But if you want the shortcut, here it is. What you do is you take this denominator, you multiply it times this. All right? So 5 times 1 gives you what? And kind of look at it like an arrow going that way. We're going to go 5 times 1, which gives you 5. Then you put the symbol that's in between, which is plus. Now you do the 8 and you multiply it times the 2, and that gives you what? 16. Okay? Then you put that over, and now you multiply these two together. 8 times 5, which is 40. And you get 21 over 40, which is what we just got a second ago. So it's this times this, plus that times that, over that times that. Let's do one more. 3/7 minus 2/5. So let's do the shortcut. How would this work? What first? 5 times 3, 15. What here?
1 times 2,
minus 7 times 2
14.
over
7 times 5,
1/35. 1 over 35. Y'all like that or no?
That's cool.
The only thing that's wrong with this method is just that there's not like an easy way for me to explain what just happened. It's just like do it and it works, okay? Yes?
You have to make sure that you multiply
That way first,
Okay.
then this one, and then straight across the bottom. Now, there are times when this would become, let's say, messy. Let me just show you. What if I had 13 over 40 plus 5, let's go 7, I'll make that a 7 over 20. What can you see would be bad when I do this?
When you multiply the bottom, it's going to give you, well, I'm talking about the common denominator.
Okay, so not that method, this short way. What would be kind of the issue here? Big numbers, right? So let me do this. I'm going to do it the shortcut. 20 times that would be 260, okay? Plus 40 times 7 would give me 280. And then on the bottom I'd have 40 times 20, which would give me 800. So I'm getting 540 over 800. Yeah, I think that's right. Okay, big numbers, you still have to reduce this, right? That's the only drawback to the shortcut is that you can get big numbers. If we did this with a common denominator, this would have worked out a lot nicer because what's the common denominator between these two? 40, right? So I just have to multiply this one by what? 2 on the top and bottom. What's that times 2? The bottom times 2? And now you just add across. So you go 27 over 40 and you're done. You see, you've got it. You've got it right here real quick. because the denominators only require 2 on top and bottom here. So does that kind of illustrate the like pros and cons a little bit? Okay, so I don't care which method you use, as long as you use something that works. All right. So addition, subtraction of fractions. Some word problems, yeah. I'm just looking to see what I want to do here. Let's just do number 15 here. Let's take a look at it. I can't do all the word problems. It'll take too long. So let's do this word problem, then we're going to take a little 5-minute break, and then we'll come back and we'll get into the next section here. Or maybe we'll do another word problem. Jerry bought 12.5 pounds of candy to share with his friends. If he gave 2.5 pounds to each to 3 friends, how much candy does he have left? So think about it for a little while. And then we'll talk about how you might go about figuring this out. Any ideas?
What's called the 2 1/2 times 3?
Okay, so you're saying he's got 12.5 pounds of candy. He's got 3 friends. He's given them each 2.5 pounds. So you're going to go after how much did he give away first, right? So you took the 2.5, you want to multiply that times 3. Does that make sense to everyone? So first starting out, let's figure out how much he gave away, which would be 3 times 2.5. Right, so to multiply that, what we should do is go back and turn these into fractions, right? The rational numbers. So what would this one be turned into a rational number? What's that? 5/2, right? So 2 times 2 is 4, add 1, we get 5/2. What about the first one? What about 3 turned into? 3/1. Okay, 3/1. And so now we can multiply that. So what do we get when we multiply? 15/2. We're going to leave it like that. We're not going to write this as a decimal. We're just going to leave it. 15/2. That's how much LBS, pounds, right? That's how much he gave away. All right? So someone else now want to tell me how they would finish it off then, because that's not the final answer. The question is asking how much does he have left? Yes?
He is left with 2.5 pounds.
How? How are you getting that? Or what are you needing to do on the next step?
Subtract.
Subtract what from what?
I have to change that 12.5 into a fraction number.
Okay.
Which means multiply 2 times 12, 24 plus 4, 25/2.
Okay, this is the pounds of candy he started with, right?
Yes.
That's the 12.5 pounds. And then minus, right? Minus the amount he gave away, 15/2, right? So please pay attention to the language I used there just a second ago. I said we're subtracting what from what, okay? Because subtraction order matters when you subtract, right? If I do 5 take away 2, that is not the same as doing 2 take away 5. So this right here, 15/2, is being subtracted from 25/2, not the other way around. So this is correct. This will give us how much he has left. So we have the same denominator, don't we? So since we have the same denominator, we just do 25 take away 15, which is 10 over 2. And 10 over 2 reduces very nicely. This is just 5 pounds. Right? Did you do something different? You didn't say 5, right? Do you see what happened? Because you had this,
I
right?
made a mistake when I subtracted 25 from 15.
Oh, okay, you just did, yeah, all right. All right, that good? Okay, each of these word problems in the homework are going to be different. They're going to be unique. And part of what I want for this first homework assignment is to see how comfortable you are with those. So I don't think I'm going to do any more word problems out of this section. Just be prepared to do in the word problems, you know, addition, subtraction, multiplication, division of fractions will appear in the problems, all right? And then what we'll do is next class, we're not done for the day. Next class, I will entertain any questions you might have on those homework problems. So if you go do your homework, you check the solution, and you can't get the answer, come to class with a question. I can help you out, okay? So we're going to take a break. Let's go with 10 minutes. So please come back here at 12:25. That's 9 minutes, close enough. All right? 12:25, we'll restart class.
Does the bookstore close?
Does it close?
Like, this is lunchtime now.
They should be open. I don't know the hours of the bookstore, but you also don't have, like after class, you saying?
Yeah.
Yeah, after class, they should be open. It's first day of classes. Yeah, I mean, they should be, right? They want to make money, right? Okay, 10 minutes. Okay, y'all ready? So we're moving on to order of operations. And I thought I'd start with a quiz. Okay, so everyone just take out a sheet of paper, a separate sheet of paper. Put your name on it. Now here's the thing about this quiz. It's one question, all right? One question only. And I'm going to give you about 1 minute to do it. All right? Does everyone have a sheet of paper out? Here we go. 12 divided by 4 times 3. Time starts now. You have 1 minute. When you're done, just flip it over. Okay, I'll collect it.
You need to put our name.
Yeah, put your name on it, please. Yeah, make sure your name is on it. Yeah. Okay. Got more back there. Anyone else?
I made a mistake.
You made a mistake? Oh, it's okay. So look, I'm only going to grade this quiz on participation. Okay, so everyone gets 100 no matter what you did. This is more to put you under a little bit of pressure for a second. See what goes on. So I'm going to sort these right here into piles of answers, okay? So, and then I'll tell you what the most common answer we got was. Okay, we have a lot of consistency here. What is this one? Okay. Give me a second. I'm almost done. Okay. So, I'm going to set these right here. These are the students in the class that answered 1. Okay? That's almost all of you. Okay? These students, 1, 2, 3, 4, 5, they freaked out in the pressure and did something completely different and got something other than 1. And then this student got the problem correct. The answer is 9. So the reason I did this is because most of you weren't necessarily taught this incorrectly, but you remember it incorrectly, perhaps. Okay? So can I embarrass the person who got it right? Is that all right? No, I won't do that. Okay. So what is this here? We're doing order of operations. What is this? Have y'all seen that before? This thing, PEMDAS. Show your hands. How many of you have seen that? Okay. Anyone never seen this? It's okay if you haven't. I'm just curious. So the way I learned this was, please excuse my dear Aunt Sally. That's the way I learned it. Anyone learn it a different way? Please excuse my dear Aunt Sally. And when I was taught this in grade school, I was told you always do this first, which stands for anything in parentheses goes first. Then E stands for exponents, which is like powers. And then this stands for multiplication, and then division, and then addition, and then subtraction. And that's the way most people learn it, but it's incorrect. So what actually needs to happen is that these two right here have to be grouped together, and these two have to be grouped together, and they are equivalent. They happen, you will never do multiplication before division or division before multiplication. You always have to look at the problem and do them in the order they appear as you read from left to right like a book. Okay, so multiplication does not dominate division. It's when you look at this, you say, okay, I have multiplication, I have division. I am not going to do multiplication first here because division appears first as I read it from left to right. Does that make sense? So I actually have to do this first. 12 divided by 4, which is 3. And then I do times 3, and that gives me 9. All right? So in this order of operations, just be sure you understand that these two get grouped left to right. These two get grouped, do them left to right. All right? So we all kind of learned, most of us learned something here. All right, so now what we're going to do is we are going to work through some problems which require us to use the order of operations. Remember, I'm going to give everybody 100, okay? Unless y'all want to take the grade, no?
No.
Okay. I actually remember being in college, taking a class, and they went through that. I wasn't a math major when I started college. And I had learned it incorrectly. I had been taught incorrectly, or maybe I remembered it incorrectly. But they gave me that example, and I was like, I was kind of pissed. You know, I was like, why didn't they make that more clear to me that it was left to right? You know? Because that's what it is. So I'm going to say I just forgot. Maybe it was my fault, but I don't want to blame my teachers. What the heck is that? I don't want this. I don't even know how I did that. All right, let's look at this first one here. We want to do 5 take away 3 plus 72 parentheses 10 take away 2. All right, so there's little tiny subtleties within the expression we have here. We're asked to perform the operations below to figure out what this is. First thing I'm going to point out is that this is what we call an expression, not an equation. An expression. So this should just, at the end, we should just have something, no equals signs anywhere, right? We're not solving an equation for x or something like that. It's just, what is this number? Simplify it. So we'll start with the order of operations. Let's go with parentheses first. So we do what's in here first, right? What's the operation between these two? Subtraction, then here? And then what about here? What's going on right there? This is an implied multiplication. This is a dot, or little cross if you want, but we don't use the crosses as much in here. We use dots. So there is an implied multiplication right here. So we have parentheses, we have multiplication, we have addition, we have subtraction. So I'm going to do what's in here first. I do 10 take away 2, and that gives me 8, right? So now this becomes 72 times 8. Now I do 72 times 8, right? That's my next thing. Order of operations, multiplication is going to go before the addition and subtraction. So you might need your calculator here, 72 times 8, just to be, I need to go out of this mode. 576. Now what should I do? Yeah, subtract, because I have addition and subtraction, right? So I'm going to be working from left to right. From left to right here. So I'll do the 5 take away 3 first, which will give me 2. And then I'll do plus 576. And that should wind up there at 578, and we're done. Make sense? How about this next one? This next one looks kind of nasty. 2 plus 2, parentheses 3, take away 6, close parentheses, minus, parentheses 1 plus another parentheses 1 minus 4, close parentheses squared, close parentheses squared. Yuck. We have multiple parentheses, so which one do you do first?
Parentheses, 3 minus 6.
Okay, so this one I could do right now, couldn't I? Now over here we have like a parentheses, and then inside of that we have another parentheses. So I should do this one, right, before I do the outer one?
Yeah.
Okay, so you always want to work your way from the inside out. But if you have two groups of parentheses, you can do them separately. Okay, so I'm going to kind of rewrite this now. 2 plus 2, what's the operation here after the 2? Multiply, so multiply. Now, let's do this. What's 3 take away 6? Negative 3, right? 3 take away 6 is negative 3. So should I write it like this? I don't know, that looks strange, doesn't it? So what we do is we put this in parentheses, so it looks like 2 times negative 3. Make sense? Okay, and then I keep going, minus parentheses 1 plus, okay, let me do what's in here. What's 1 take away 4? Negative 3, right? Ooh, this is tricky. It's negative 3, and then what am I going to do with that negative 3 after I get negative 3? I'm going to square it, right? So watch the way I write this. I'm going to go negative 3, that's what this became, and then squared, right? And then I'm going to do my next parenthesis and then squared again. Okay, so I'm taking my time, one line at a time, working through. Okay, here, 2 plus 2 times negative 3 minus, I'm not even going to do that. I could multiply it, but I'm not going to. 1 plus, okay, I have to do this exponent, right? Before I do this parenthesis, because I'm still working within this parenthesis. Exponents come before that addition. What is negative 3 squared?
Positive.
So is it positive 9 or negative 9?
Negative 3 times negative 3.
Negative 3 times negative 3 would be positive. So this is a positive 9. Right? That's what this is. And then we have the closed parenthesis, and then we have squared still. Notice how I'm writing each line, trying to illustrate like each step. That's part of what math is about, is being somewhat precise in your writing. I mean, you could try and do these steps in your head, but if you get it wrong on a test, then I have to take off a lot of points. If you do step by step and I see, oh, here to here they put negative 9. Like I can see, oh, that's a minor thing compared to just a wrong answer with no work. So what I'm saying is show as much work as you can to receive as much credit as I can possibly give you. 2 plus 2 times negative 3. Okay, I'm going to do what's in parentheses here, right? So that's 10. But then we still have squared. So in that step I did this. This step was here. Yeah, that step was that. What next? I square 10. Do I square negative 10 or do I square 10? Just 10 because this minus sign is out in front, right? The 10 is being squared, not the minus. So this has become 2 plus 2 times negative 3 minus 10 squared, 100. And we keep going. What should I do next? Next line. Multiply 2 times negative 3.
That's
Negative 6, right? So what should I write here? I'm going to have 2 plus negative 6 is the same as 2 minus 6. So we're just going to write 2 minus 6 and then minus 100. Any questions on that? doing this was there, and then from here, I did those two together. That became the -6. Does everyone understand why I'm not writing 2 plus -6? On this step, 2 plus -6. That 2 plus a negative is the same as subtraction. So that's why I put 2 minus. Okay, at this point, we should be able to just crank this one out. 2 take away 6, -4, and then take away 100. -104. -104. Questions, comments? Yes?
Why don't you stay on the right side of the equation the entire time?
What I'm doing is I'm saying that this expression is equal to this expression, which is equal to this expression, which is equal to this expression. I'm not working with two sides of an equation. I think what you're maybe saying is that, like, if I had, I'm getting ahead of myself here, but if you had like an equation, then you have two sides of an equation. You have a left side and a right side. What we're saying here is we're not starting with an equation. We're starting with some expression, okay? And we're saying that expression is equal to this new expression, which is equal to this new expression. So it's like this is equal to this is equal to this, which is this at the end, okay? So that's equal to that, to that, to that, which is -104. As opposed to left and right, does that clarify, or you sure? Okay. All right, so we're good? And as you might imagine, you can just start making these uglier and nastier, more parentheses, fractions, all sorts of things, right? So let's see how bad this gets. Need to get rid of that. Delete that. There we go. You pick. There's a couple to pick from. Let's pick two of these for me to do. Number 9. Okay. I'll do number 9. What else?
12.
12? 9 and 12? All right. I can't do them all. I mean, we just don't have time. So 9 and 12. Let me start with 9. A little bit bigger for you there. I'm glad you picked 9 because I'm very curious to see what you do with the denominator there. But let me write it out first. So before I do this, I want us to see something before I do this. What is -1 squared versus -1 squared? Are those the same thing? Do you get the same answer or not?
Yes.
This one means you're squaring -1, right? So this means you're taking -1 and multiplying it times itself. Negative times negative is positive. This does not mean you're squaring -1. You're actually squaring just the 1, which is kind of ridiculous, but what's 1 squared? What's 1 times 1? 1, but you still have a negative outside, so you get -1. Let me illustrate this a different way. -4 squared versus -4 squared. This one gives you positive 16, this one gives you negative 16. So the parentheses are absolutely vital to knowing whether or not you get a positive or negative answer. All right? So when we look at this problem here, this is the first one we've done where we have a fraction. You know how we have order of operations? It doesn't say anything really about fractions, does it? But it turns out that when you have a fraction, what you do is you do the order of operations on the top, you do your PEMDAS, do it, figure it out, get an answer. Then you do PEMDAS on the bottom, and then once you're done with both, you put them together. So you keep them completely separated until the very end, you put them together. So let's do PEMDAS on top, I guess. Let's do what's in here first. So what's going to happen in here? multiplication. So that's just going to become 4 plus 6, because 3 times 2. And then plus, what about in the other parentheses? I can just multiply that. That gives me negative 3. Now, let me go ahead and do the bottom now. What's that negative 1 squared? Negative 1. Okay, we can start putting this together now. 4 plus 6, 10, and then plus a negative. So that's 10, take away 3. Isn't that the same thing? And then over negative 1. So the top is 7 and divided by negative 1. And that's going to give you negative 7. Make sense or no? All right. The other one was 12, right? That's what you were looking at? Okay, I'm going to give you an opportunity to get that one going for number 12. Here's what I'd like for you to do. Work it out on your own. You're not going to turn it in or anything. Work it out. You can talk to each other if you want. What does this mean, just so we're clear? What do those 2 bars around that mean? The what? Absolute value. And what is the absolute value of any number? It's just whatever that number is, positive. Okay? So the absolute value of negative 5 is 5. All right? The absolute value of 5 would also be 5. So it's like if it's the absolute value of a negative, it becomes positive. If it's the absolute value of a positive, it just stays positive. So it always just spits out the positive answer. Does that make sense? Okay, take a moment to see, a couple of moments to see if you can figure out number 12. Everybody signed in? Okay. When you finish, please just raise your hand real quick. I just want to kind of see how long it's taking people to get through these. Done? Okay. You're done? Okay, thank you. Okay. Okay. Thank you. Okay. Got about half the class done. Okay, thank you. Just another 30 seconds maybe. Okay, I think that's good. So next time when I give you those little sticks, this would be a time where I would pull a stick and be like, okay, let's go. See, and what I would do is say, what did you do? What was your first step? And I would just go through, and the whole goal with those sticks is to get through every single person in the class each day. And if I can do that, then I don't have to take attendance. I can just do the sticks. All right, so Anyone want to tell me what they did first, or tell me what they got as an answer? Anything, I don't care. Negative 27 is the final answer. Let's take a vote. Negative 27? Okay, well then we'll just say that's right. No. Let me work through it. So, okay, you got negative 27. So can you tell me what you got in this parenthesis when you were done?
With that.
With just in this parenthesis, what did you get there? Negative 1, correct. So this should have turned out to be 4 minus 5, which is negative 1. And then in this parenthesis, that's 5, right? And then squared. Okay. So now you have to multiply 2 times negative 1, which gives you negative 2. I should have actually done that first, sorry, but I can do them separately. 5 squared, 25. Why is it not negative 25? Yeah, the squared is on the parenthesis part. The parenthesis part turned out to be 5. The negative is out in front. So that's 25, but then negative. And yes, together that's negative 27. Okay? Let's look back at that list again and see if there's maybe one more that looks bad to you. We did number 9, we did number 12. Anything else there look bad that you might want to go through? No? You're happy? Number 10 look weird to you? Okay, number 10. We'll try it. See what you get. Quick show of hands. How many of you are good up to here? Anyone have a question on anything prior to this? We're okay? This is a little bit tricky. And let me illustrate this with a different problem that will illustrate the trickiness of it. All right? Let me show you something. What is 12 divided by 3 divided by 4? What's 12 over 3 over 4? 1. So where are you getting 1 from?
4 over 4.
Where are you getting 4 from?
You divide the
12 divided by 3, which would be 4. So 4 over 4, which would be 1. Okay. I get that, but what if I did 3 divided by 4 first? Right? So just someone on their calculator real quick, do 3 divided by 4, you get 0.75. Right? So you could look at this as being 12 divided by 0.75, and if I do that on my calculator, I get 16. So is it 1 or is it 16? Do y'all see the difference between how I just did that? To get this answer, you do 12 divided by 3 first and get 4, and then 4 over 4 is 1. But you can get that answer if you do it 3 divided by 4 first and then do divided by 12, right? And it's all division, so what goes first, right? Order of operations doesn't help because it's all division. Y'all with me? Mm-hmm. So there's something subtle here that we have to pay attention to, and that is this division bar, okay? That division bar right here, and here, it's this one, right? Okay, so what I'm gonna do is I'm gonna make this division bar longer than the other division bar, like that. And what that tells you is which to do first. So like back over here, I gave you this. This is actually incorrect. Like for me as a math person, to write this way is bad. I have to tell you which way I want you to do it, this way or this way. So if I want you to do it this way, what I need to do is make the bar like that. Then you will do 12 divided by 3 first, and that will be 4 over 4 is 1. If I want you to do it this way, then I needed to have written it this way. Do y'all see the difference between those two? That's critically important, and that's what helps us figure out what to do here. Okay? So now, at this point, what I'm going to do is this. I'm going to erase this. And now I'm going to rewrite this as 14 over 15 divided by 8 over 1. So what I'm doing is I'm going to rewrite this as a fraction and then rewrite that as a fraction. Okay, 8 over 1 with the long division bar here. And now realize that this is the same as me asking you this question, 14 over 15 divided by 8 over 1. Isn't that the same thing? 14 over 15 divided by 8 over 1. And so how do we do that? You have to flip the second one over and make it multiplication. So this becomes 14 over 15 times 1 over 8. And now we're back to where we started class, aren't we? And I can actually reduce. 2 goes in there 7, 2 goes in there 4. So you get 7 over 60. All right, so your goal here with these problems is to go home and practice and get yourself comfortable. You want to get to a point where you're comfortable with these, where you look at the problem and you're not sitting there just like, what do I do? You know? Yeah. All right. So I was talking to someone the other day, my neighbor, she just started working. She's in high school, she just started working. And she asked me if I could help her figure out how many hours she would have to work in order to make like $300 a week or something like that. And I said, well, you're in high school, what math have you taken? She said, oh, I've taken this and that. I said, you can solve the problem, you just have to turn it into the math. So I want to start this by, I'm going to give you what her problem was, all right? So her problem was basically this. She said, I make, I think it was $9.40 an hour, okay? And she wanted to make $300 in a week.